Good afternoon, or morning, or evening, whichever it may be. Today we're going to learn about finding the sum of a finite geometric series. Last time we did the sum of an arithmetic series, so hopefully that's familiar to you. Today we're going to do the sum of a finite geometric series, which is a little bit harder than the arithmetic series. Now, by all means, since it's a finite series, you could just easily, if you wanted to, it's just time consuming, write down all the terms and add them up. So for instance, this expression here starts at n equaling 1 and goes up to 6, so there'll be 6 terms. So I plug a 1 in here, that's 4 to the 1 is 4, times 2 is 8. So my first term is 8. But then I'm going to add that to my second term, which I got to plug a 2 there, and 4 squared is 16. 16 times 2 is 32. And then I'm going to add that to, now I'm just going to realize I'm timesing by 4, so I'm going to multiply this by 4, because that's basically what the geometric means, is that we're getting from one term to the next by multiplying by a common ratio. So if I multiply this by 4, I get 128. If I multiply this by 4, and by the way, nothing wrong or against using a good old calculator, right? So 128 times 4 gives me 512. Times 4 gives me 2048. 2048. I have 1, 2, 3, 4, 5 terms. I need 6, so I'm going to times by 4. And get 8,192. And then I could take the time to add those all up. So I'm going to take that 8,192, add it to the 2,048, add it to the 512, add it to the 128, add it to the 32, add it to the 8, and get a final sum of 10,920. But let's say that there was 20 terms or 50 terms. This could get very, very, very time consuming if you did it term by term. So there is a formula, which in later years you will learn to actually derive this formula in higher mathematics. But in this lesson, in this year, I'm just going to give you the formula. So to find the sum of a finite, meaning there's a finite number of terms, finite geometric series, I should learn to spell correctly, is this. The sum is equal to, you're going to take your first term, okay? So I'm going to do A1 for your first term, okay? It's going to be in a fraction, but you're going to times A1 by 1 minus the ratio what you're multiplying by. So, if I'm multiplying by 4, R will be a 4, raised to the K, where K is the number of terms I have, and all of that product is divided by 1 minus the ratio again. No exponent on the bottom one. So let's do that with this sequence, the one I have here, to see if we get the same number. So for this sequence, the first term again was what? First term was 8. I'm going to multiply that by 1 minus, now again, what am I multiplying by? What's my common ratio? Well, I'm multiplying by 4. It's the number that has the exponent on the formula. I'm multiplying by 4, so I'm going to do 1 minus 4, but that 4 is going to be raised to the number of terms I have. And I can see in the formula here, if I go from 1 to 6, that means I'm raising it to 6 terms. Or so I raise it to the 6th power, and I divide by 1 minus 4. 4 again being the ratio. No exponent on this one. So let's see if that actually equals 10,920. So 8 times 1 minus. Now again, you do use a calculator here. So I am going to do the 1 minus the 4 raised to the 6th power. Maybe I should have just did 4 to the 6th power. but it'd be 1 minus 4,096. 4,096. I just actually minused it from 1. So that right there is going to be the -4. So that's all over -3. So we get a 8 times that -4095 divided by 3. So I'm going to do that times 8. So we get a -32,760 divided by -3. So I divide by -3, and I get, of all things, 10,920, which is exactly what I had up here. So I would recommend you try to get 10,920. Get used to, or at least familiar with that formula, because you will see it in later years. So again, see, here's 10 terms. So again, for this one here, in order to do the 10 terms, I'm going to first find what the first term is. I'm going to plug a 1 in there. 2 to the 1 is 2. 2 times 3 is 6. So my sum is going to be 6 times 1 minus, and what am I multiplying by? This common ratio of 2 raised to the, how many terms are there if I'm going from 1 to 10? There's 10 terms, so raised to the 10th power, all over 1 minus my common ratio of 2. So again, on my calculator, and I'm going to show you how quickly you can do this on a decent calculator. Let's make sure you can see the equation here. I'm just going to go 6 times, in parentheses, 1 minus 2 raised to the 10th power. Whoops, I put my parentheses. I want to exit, there we go. I'm going to hit equals there, so I just did the numerator. That's this numerator. And then I'm going to divide it by, well, I'm dividing by -1. So maybe that number, I knew I just needed to change the sign. So that sum of this series, this finite series, is 6,138. So again, be careful with your fractions. The reason they do this is make this process is because it becomes easier and easier to do when it's with fractions versus doing each term individually. So the first thing I'm going to do for this one here is I'm going to find, now again, if you don't have that written down, I would write this formula down right there, right? So the first thing I'm going to do is take the first term, I'm going to times it by 1 minus whatever ratio I'm timesing by, raised to the exponent of how many terms there are, all over 1 minus r. So let's do that. Let's first find my first term. If I plug a 1 in here, 1 minus 1 is 0. 2/3 to the 0 power is 1. 1 times 4 is 4. So my first term is 4. Then I'm going to do 1 minus my common ratio, which is what has the exponent, so the 2/3. But that, now be careful here, that 2/3 is raised, not the 1 minus 2/3. The 2/3 is raised to how many exponents there are. If I go from 1 to 7, that's 7. All over 1 minus, again, that common ratio of 2/3. So we got 4 times 1 minus, and now again, you can do this in steps on your calculator, or you can do it all at once. But I'm going to do it all at once, actually, to show you. I think it's better to do it all at once than, because you don't have rounding errors. So here we go. I'm going to go 4 times, in parentheses, 1 minus. I'm going to do parentheses to make sure I put the fraction in parentheses. I'm going to do that 2/3 in parentheses, its own set of parentheses, raised to the 7th power. Now I'm going to arrow over to get out from underneath the exponent, parentheses. Now I could just hit enter and then divide, but if I wanted to, I could divide by that 1 minus 2/3. So I'm just going to put divide. Now I'm going to do parentheses, because I got to make sure I follow order of operations. I got to do that minus that's in the denominator first. So 1 minus, Well, 1 minus 2/3 is just 1/3. I might just type in 1/3. But just to show you how I would do it in case I didn't, I'd do 1 minus. Now again, I'm going to do another open parentheses because I want that 2/3 to be done first, right? So I'm making sure I follow order of operations, making sure my calculator does this fraction before it does this subtraction, right? Then close parentheses, and that denominator is completely in parentheses, and then I hit enter, and I get 11.29766684. Oh, let's see. Now let's hit math and see if it has a fraction representation of that. Write your answer as an integer or a decimal rounded to the nearest thousands. So it doesn't want it as a fraction. There would be your fraction. But since it wants it as a decimal, I'm just going to type in 11 to the nearest thousandth. So make sure you remember how far is 1,000. There's tens, hundreds, thousands. So the number to the right of the thousands place is a 6. So that 7 is going to go up to an 8. So it'll be 11.298. 11.298. We submit. And look at that. We did it correctly. So again, hopefully this will allow you to do this assignment. Again, it's not really difficult. It's just having this formula written down and having a calculator that you know how to work in order to get that sum of a finite geometric series. If you do have questions, though, please do get a hold of me and I will help you.